Hey, everybody. 777. The Hong Kong dollar is arguably the most successful stablecoin in human history. It's been around since 1983. It's got a market cap of over $2 trillion, and it has never depegged. This is a model of success. It stood the test of time. It's resilient. It's securing trillions of dollars in value. As we look to revolutionize the traditional finance world with on-chain finance, we can take inspiration from the Hong Kong dollar. Because success like this is achievable. You just need a strong foundation. We need a strong foundation to fulfill the potential of this industry so that 5 or 10 years from now, when we look back at what we're building together, we can have the same or even greater level of success as 777. We're lucky to be in an industry that has so much potential. We've been waiting for a catalyst to move us into the mainstream. Just like email kicked off the internet revolution, so now we're seeing tokenization kick off the on-chain financial revolution. Tokenization is the catalyst that's going to take our industry into the mainstream. The WEF estimates almost $900 trillion of assets are going to get tokenized. And as much as 10% of GDP is going to be on blockchains by 2030. And the Bank of New York Mellon estimates 97% of asset managers believe that tokenization is going to revolutionize the asset management industry. The journey has already begun, with $170 billion of assets already tokenized across 5 different asset classes. The magnitude of this revolution is like nothing we've seen in financial history. Hundreds of trillions of dollars getting reformatted from an existing technology stack onto a new technology stack. This will include, of course, all of the spot markets of all the major asset classes, as well as their corresponding derivatives markets, which are typically multiples the size of the spot markets. And for those of you in the financial industry, you will know that there's also, besides the big asset classes, there's a very long tail of investment opportunities that are typically bucketed together as alternative investments. These are typically uneconomic to build investment products around, like funds. But one of the promises that's so interesting with tokenization is that it's going to collapse the operational overhead associated with these investment products. And it's going to suddenly make numerous investment assets viable for things like funds. To handle this innovation that will follow will be staggering in terms of its creativity and its magnitude. I mean, look at these numbers. To handle these magnitudes and that velocity, we're going to need infrastructure and applications. That is going to be a requirement if we really want to achieve the success that we really going to get to. It starts with having secure, reliable, and scalable infrastructure that can be resilient to handle these magnitudes. On top of that, we're building financial applications, so things like compliance, verifiability, and privacy cannot be an afterthought. These things have to be integrated from day one. On top of that, you need common standards to enable people to access all of these capabilities in a consistent manner. And last but not least, for developers, you need a great user experience and great tooling so that they can focus on creativity and innovating and access all of these capabilities in an easy fashion. That's what a great foundation looks like. At Chainlink, we've known this for years now, and we've been at it since 2019. Some of you may remember back in the day when blockchains first kicked off, smart contracts were not very functional. They were disconnected from the real world. All this changed in 2019 when we launched our price feeds on Ethereum mainnet. And suddenly, on-chain contracts and assets and the off-chain world became connected. And there was a burst of innovation, and billions of dollars came into the space. There was an explosion in activity that culminated with the DeFi summer of 2020. 5 years later, we're still at it, and we've become the premier infrastructure service provider for Web3. We've expanded the scope of our products and services to meet the growing complexity and growing demand of the DeFi space. Today, Chainlink offers data services, cross-chain interoperability, and compute services that are used by thousands of developers and projects out there, including some of you here. We've, on aggregate, published over 15 billion verified messages on-chain across our services across multiple blockchains. And we've enabled over $16 trillion of value. This is the scale we're operating at. The great thing about the foundation we've built is that it's already enabling the adoption journey for financial market infrastructures, banks, and asset managers. Fidelity International and Sygnum Bank have partnered with us to bring on-chain data for NAV for their tokenized fund. Euroclear, Swift, and 6 other institutions worked with us to showcase how AI and blockchain oracles can be combined to revolutionize how corporate actions are managed. The DTCC, along with 10 other institutions, worked with us to bring NAV data on-chain for tokenized assets. And of course, Swift and Chainlink, as you heard earlier, are working on a joint project aimed at facilitating interbank transactions using the Swift network, Chainlink CCIP, and blockchains. The capital markets are ready, and we're excited for the work ahead with them over the coming months. This Chainlink platform is the only platform capable of providing end-to-end blockchain-enabled workflows. Our products are secure and reliable and interoperate seamlessly between Web2 systems and the Web3 ecosystem. This is the foundation you need to realize the potential of this technology to help you achieve the level of success of 777. But our platform isn't static. We keep evolving it and adding more capabilities to it so it can be even more useful for you. Let's take a look at some of these new additions that I think you're going to really like. As you heard, DECO, privacy and compliance cannot be an afterthought. That's why we're launching a suite of solutions to address data and privacy. It's a zero-knowledge Oracle technology for authenticating data privately, a way of verifying sensitive information without revealing the underlying data. This sandbox is going to be pre-configured for use cases around identity, proof of funds, and sanction screening. Join Lawrence tomorrow for this presentation. It's going to be really interesting. But of course, what we're doing with DECO is only one of the ways that we're using data to enable the adoption of tokenized assets. And I want to invite on stage Zhang to tell you more about some of the other things we're doing on the data side. Thank you so much.
Our vision for Chainlink data is to be the essential infrastructure for the tokenized economy. And we believe this tokenized economy will be underpinned by data-rich, data-powered, smart assets. Now, you've heard Ghando talk about how tokenization will be a massive game changer for on-chain finance. But the next generation of these smart assets, they need smarter services, they need new types of data, and they need scalable infrastructure in order to hit the escape velocity that's needed for hypergrowth. Now, Chainlink is on the front lines here, working in lockstep with asset issuers, builders, to solve some of the key data challenges around tokenization. The problems we're tackling today includes standardizing data formats and structures to support smart contract workflows, expanding the range and the depth of asset servicing data, as well as scaling data delivery of complex financial data from on-chain to cross-chain. Tokenized real-world assets in particular, they need more than just the price data and asset transparency that we provide today. Now, to transform static on-chain representations of real-world assets into a dynamic smart asset, we need TradFi-grade asset servicing infrastructure that delivers high-quality data in a secure, scalable, and reliable manner. Now, Chainlink is uniquely positioned to bring this to bear. Today, I'm excited to share with all of you the new gold standard for tokenized asset servicing. Introducing SmartData. SmartData is Chainlink's new suite of data asset services for tokenized real-world assets. SmartData embodies Chainlink's vision to be the essential infrastructure bridging TradFi and DeFi. With SmartData, your tokenized assets will have access to real-time asset servicing data delivered directly from the canonical source to the blockchain. Our current data integrations include reserve verification data through our flagship Proof of Reserve product, as well as asset under management, net asset value, and other collateral information. We're also rapidly expanding our asset data coverage to meet your tokenization needs. SmartData transforms your tokenized assets into highly programmable on-chain smart assets and offers robust minting protection powered by Proof of Reserves. Just as the sound policies of Hong Kong anchor the Hong Kong dollar's 777 currency peg, SmartData maintains a golden record of the critical data that you need to anchor your tokenized assets, making it smarter to use and safer to manage. And we're already partnering, as you can see here, with leading asset managers and token issuers across a wide range of RWA asset classes to integrate with SmartData today. Reach out to me or any of our Chainlink associates at SmartCon if you're interested to learn more about SmartData and to build smarter tokenized assets with us. Now, finally, I want to share a sneak preview of something else that we've been cooking in the kitchen. Beyond data accessibility, we think asset discovery can be much more streamlined to help investors navigate the expanding universe of tokenized assets. And this is our vision, a new tokenized assets data hub. This will be built on our data.chain.link data product portal. Data Hub will be your one-stop shop to search, to view, and to find comprehensive information on tokenized assets, such as the reserve details, the token issuers, asset composition, and much more. This will position Chainlink at the epicenter of tokenized asset discoverability, making information much more accessible throughout the on-chain economy. Now, if you would like to find out more about all the exciting data products that we're building and market trends that are transforming on-chain finance, come to one of our sessions here. We'll be sharing more in all of these deep dives. And now I'm pleased to bring on Anurag from ANZ Bank, a valuable Chainlink partner, to share about enhancing transaction privacy through CCIP. Thank you.
Big thank you to the Chainlink community for inviting us to be here. I just want to start with a quick recap. Last year, when we were at SmartCon, we presented how customer on one chain can purchase an asset on the other chain and get it delivered to them in a seamless fashion. It worked perfectly. Small problem. It works perfectly for public assets. What if the assets are private in nature? No solution? Last 1 year, we have been working hard with Chainlink team to solve this problem. The problem is twofold. That if these assets are private, you want to preserve the privacy at the network level and also while they're in transit. So 2 parts. Remember that. Because at my last slide, I will ask what were the problems. The second challenge we gave ourselves is we wanted to use the same infrastructure of Chainlink oracles so we can solve this problem in a scalable manner. This is a very, very big platform shift. And big platform shifts take time. Not just because it takes time to build things, but the risk which these new platforms present. And to better understand these risks, I said, why not? Let's do a PhD. So what you have on the screen is the mental model which I apply to understand these risks and how we can manage it. This is a diagram from one of my research papers with Dr. Tallis and Dr. Mark Staples. What you're seeing is at very bottom is the network layer where all the nodes exist. Above that is the consensus layer. Above that is the protocol layer. Protocol layer is the most important part for our conversation today. To have a Web3-enabled interoperable solution, you need to have interoperability contracts present at the protocol layer. If CCIP contracts are present at the protocol layer, to make sure that privacy is preserved, we have to provide selective access to the Oracle nodes to this contract. Because otherwise, if we give the entire access to the Oracle network to this layer, they can see all the transactions. And guess what? Privacy is important to the network layer. The second part is, if we are able to achieve the selective privacy, what about privacy in transit? That was the second problem, because Oracle network, all the data goes through, is publicly available. So these two are the big risk surface area which we wanted to solve. Now, a big drum roll. How did we solve it? Excited to see? Raise your hands. Yeah? Cool. We solve it using CCIP private transactions. I will quickly walk you through how it works. When a sender wants to send value and data across chain, first step which happens is CCIP contracts encrypts both data and the value, which ensures the problem of privacy in transit. Because if it is encrypted, Oracle node operators will not able to see how much value is going through the chain and what data it corresponds to. Example, if you are subscribing for a debt issuance, people will not able to see what is the price which you have, which you are subscribing for which particular issuance. So that is protected. Other thing is how we ensure that Oracle network is not able to see the entire activity of the protocol layer. We achieve with Privacy Manager. Privacy Manager ensures that the Oracle network only see the activity which is associated with the CCIP contracts for the events which are going on these chains. Now, it may sound like I'm just talking about private chains. No. The other big thing which it solves is, imagine you have a private chain which want to interoperate with all the public chains. Now, to do that, the most important thing is privacy at the network level. If there's a private chain which has the Privacy Manager enabled, what they will able to do is they will able to interoperate today, for example, with 17 public chains which has CCIP contracts deployed on them. All you have to do is, I want to send my tokens to this chain address, it's called chain selector, to be very specific. Now, this is not the only risk mitigant which exists here. From institutional perspective, we want to make sure that only the right tokens reaches the right place at the right volume. So all those features are also, with this deployment, we are able to take advantage of. Given we have done this work, we aim to focus on now making our customers transact with digital asset, doesn't matter where they're present, public chain or private chain. Hope you found it useful, and I will do a Sergey now. Thank you all.
Thank you, Anurag. I'm excited to introduce CCIP v1.5, the next major version release for CCIP. With v1.5, we're introducing self-serve token onboarding. This means that for the first time, token developers can permissionlessly manage and onboard their tokens. Let's go into a bit more detail as to what that actually means. First of all, token developers can deploy cross-chain tokens entirely on their own. This applies for launching new tokens, as well as taking existing tokens cross-chain using CCIP. Token developers can also manage cross-chain tokens. If you've ever deployed a token to a large number of chains, you know just how meticulous it can be to manage all that cross-chain state. We wanted to build a single, simple, and streamlined interface to manage all those settings. To that effect, we're launching the Token Manager. Using the Token Manager, token developers can configure key parameters, such as token pool rate limits, on all chains. Token developers can also configure their token to grow to additional networks as CCIP grows to additional networks. I'm excited to say that self-serve onboarding launches on testnet starting today. The docs are already live, and if you're interested to learn more, I recommend joining the developer bootcamps. Mainnet is launching soon over the next few weeks, and along with that will come the launch of the Token Manager interface. Next up, we're introducing Token Developer Attestation. For the first time, token developers can participate in the network security of CCIP. They can do this by independently attesting that tokens were burned on the source chain before CCIP can mint them on the destination. We're proud to say that we're launching this in partnership with Lombard and their LBTC token. As you can see in the diagram above, Lombard is providing an independent third-party attestation API that'll confirm that the LBTC tokens were indeed burned on source before CCIP can mint them via the off-ramp on the destination. Though this is not part of the self-serve capabilities, I am excited to say that it's launching in private beta starting today. If you're interested in learning more, please reach out to our go-to-market team. With all of these exciting new capabilities for CCIP tokens, we thought we'd take the opportunity to wrap all of this into a single standard that we now call cross-chain tokens. By leveraging cross-chain tokens, developers will benefit from all the great capabilities that CCIP already has, including programmatic token transfers and our defense-in-depth security model. Beyond that, developers will continue to benefit from the new features that we release, including the self-serve deployments, token developer attestations, and more in the future. To learn more about cross-chain tokens, I'd recommend joining the CCIP deep dive that's scheduled for tomorrow. Next up, I'd like to welcome a very special guest, Jakov from Lido, who's going to be speaking about a really great CCIP use case. Thank you.
All right. Hello, everybody. Once again, my name is Jakov. I'm Master of DeFi, contributor to Lido DAO. And today, I'm very excited to be announcing a fruit of collaboration between Chainlink and Lido, built on top of Chainlink CCIP technology. It's essentially a way for users on L2s to stake to Lido without going manually to Ethereum mainnet, which means that Lido staking finally goes cross-chain with CCIP. So what it is, how it works, it's very simple. So for users, the idea is to replicate the user experience that is available on Ethereum mainnet, which means that end user is now on an L2, initially either on Arbitrum, Optimism, or Base, holds native ETH or wrapped ETH, and is able to deposit it to direct staking protocol. Once the deposit happens, that deposit gets shuttled using CCIP back to Ethereum mainnet, gets staked to Lido. The artifact is wrap staked ETH, which then gets routed using a canonical or native L2 bridge back to the destination network and to the end user. It's really important to use the native bridge to avoid liquidity fragmentation. So that's one way of operating it. As you might have noticed, there is a need for every transaction to do this shuttle process, which takes some time, depending on the network. So there is another way which provides similar user experience, but is much faster. Again, user is able to deposit ETH or wrapped ETH. But this time, depending on the size of the deposit, he's tapping into a local liquidity pool that already holds some amount of wrapped staked ETH. This liquidity pool also contains a rate between wrapped staked ETH and ETH that is reflected from Ethereum mainnet. And if the size of the liquidity pool is sufficient to satisfy this deposit, then what happens is that deposit actually gets swapped inside the liquidity pool, and user gets wrapped staked ETH immediately in a single transaction in a single block. But then, since there is a liquidity pool, the pool gets disbalanced. There will be more ETH coming in and more wrapped staked ETH coming out. So what happens then? The flow that I just mentioned in the slide before will actually be used as automation in this flow. So there will be automation process that will rebalance the pool periodically. When there will be some amount of ETH above threshold, automation will trigger, and this ETH will be sent using Chainlink CCIP back to Ethereum mainnet, staked into Lido, and in this case, not sent to the end user, but end user in this case will be a liquidity pool. And the pool will get restored, replenished. So who is this even for? Why do we need it? Why not just buying wrapped staked ETH of decentralized exchanges that are already available and there is a pretty decent amount of liquidity? Well, DEXs are good for a lot of use cases. But if you don't want to be exposed to a slippage, if you want to get like a static ratio, or if you just want to use a simple user experience that you also have on Ethereum mainnet, you would want to use something like this. So the target is, there are multiple targets. First, end users, the ones that are using Lido as a staking service, and think that this is the best way for them to stake and earn validator rewards. They would be accessing now from L2s without spending too much on gas cost. And the idea is to get direct staking integrated into all of the major access points. So we are talking about wallets, we are talking about custodians, bridges, and staking UIs, and also DEP UIs. Another really, really important aspect that I think it's gonna be displayed even better in the future once everybody starts thinking a bit more, what can we even unlock with something like this? But something that comes to mind right now is, for example, DEX aggregators. So imagine a DEX aggregator on L2. Obviously, it aggregates DEX liquidity. But in most of the cases, if you want to trade, you will not get the same ratio as you would be getting on Ethereum mainnet. So on Ethereum mainnet, you have a choice. If the price on DEX is not good, you go to Lido and stake. But there is a caveat, there is a gas cost. Well, on L2, this gas cost is very minimal. So in a lot of cases, going to direct staking is going to be a better option than using a DEX. So what if DEX aggregator integrates direct staking as a route? Even more interesting, on lending markets and strategy vaults for using staked ETH as a collateral to do recursive staking. On L2s, it doesn't scale really well, because you have to deposit staked ETH as a collateral, borrow ETH, and then you have to swap it for staked ETH to deposit it again. But now, we are replicating the same experience as it's available on Ethereum mainnet, because borrowed ETH can be deposited to direct staking, and this staked ETH gathered from direct staking can then be supplied and looped multiple times until you extract the maximum value from arbitrage. So yeah, that's all for now. Thank you. I'll be around, so if you have any questions, if you want to collaborate, feel free to get to me. And thank you. I'll be now introducing Raoul, who is going to be talking about data streams.
So I'll be switching gears a little bit and talking about a different product. We're going from CCIP to data streams. 12 months ago, on this stage, we launched Chainlink data streams. With data feeds, we solved the Oracle problem by bringing data that exists off-chain, on-chain. But it wasn't fast enough. We needed more, we needed it faster, we needed it on more chains. And that's why we originally launched data streams. Now, we've seen the market react, and we've gotten billions and billions of dollars of trading volume and millions of data points added on-chain. But it's time to build a lot more. So I'm very happy to say that we are going to be shipping to 7 chains in 7 weeks. It's time for data streams to go live, to go vertical, and to get into users' hands. We are already live on OPBNB and Sonium Minato, and very soon we are going to launch on Optimism, Scroll, Mantle, and ZK Sync Era. And we are deploying to those chains to support the growing user demand. Users like KiloX on OPBNB, like HoldStation, a build project with billions of dollars of volume on ZK Sync Era, like Syn Futures, Zaros, and many, many others. We know that we're on the right track with data streams because we're seeing users react. And these users need a lot of data, but not just of crypto assets anymore. We're here to bring the off-chain world on-chain, and for that reason, we're also launching RWA feeds, starting with gold, silver, and oil, and 7 G10 currencies. These will be available at extremely low latency and super high accuracy. If you want access to these, please reach out to me. I'll get you set up. I'd love to see what you're going to build. Now, 2 slides ago, I said we are deploying to 7 chains in 7 weeks, but there were only 6 chains there. So I'm very proud to say that we are now live on Solana with Chainlink data streams. This means that instantly available are extremely high accuracy and super low latency prices for any user. It's in early access, so again here, if you want to build something, please come to me, I'll get you set up, or reach out to anybody in the GTM organization. And as we originally launched on Arbitrum with the GMX community, we're doing so again on Solana, with GMX Solana. GMX Solana is a community project run by some of the biggest brains in their community. They took the battle-tested code of GMX v2, translated it into Rust, and are deploying it to Solana to get that battle-tested, reliable architecture together with the unique user experience of Solana. And I'm very excited to see them go live in a little bit. Now, I told you what we've done over the last 12 months and what we'll be doing over the next 7 weeks. But I also want to give you a little bit of a peek in the kitchen of what we're going to be doing over the next 12 months. The slogan that I like to use for this is any data on any chain at scale. It's not enough to have a little bit of data. We need to get whatever it is that you need, wherever you are, and enormous amounts of it. And I want to take you through 2 architectural changes that we're doing on the engineering side to make that possible. The first is we're going to go to what we call a channel-based architecture. What that means is all the way on the left side, we can get you any input and do any compute on that. If you can find an API for it, we can go and get it. Whether that's off-chain data, whether it's a smart contract value, whether it's a price, we don't mind. We can go and get it for you. Then we update that 4 times per second, and we put it into what we call a stream. And then all the way at the end, you're going to have thousands and thousands of these streams updating at 250 millisecond intervals. That's a lot of data. So how do you make sense of that? You make sense of that by picking and choosing exactly the pieces that you need. Because everybody needs a lot of data, but what you need is unique to your protocol. The second thing that we're going to be doing is enabling all that scale. Because I said thousands of feeds. So that means that we need to change up how our DON works in what we call a multi-stream architecture. This means that we found a way to enable our DON to scale by 50x. We're going to go from hundreds of streams to thousands and tens of thousands of streams. What that means is that if you have any unique requirement, you need a TWAP, you need an interest rate, you need whatever it is that you like, you can come to us and we'll help you get it set up. So if you have any data that you want to share with the world, or if you need any data, whatever it may be, please do reach out. I'd love to talk to you. Now, we're doing all of this and we're building all of this for the builders. So I want to bring on stage one of our builders. They've gone live only a couple months ago, but they've done billions and billions of dollars of volume already. And that's Lei, the co-founder of JOJO Exchange. Welcome, Lei.
Yeah.
You're the co-founder of JOJO Exchange.
Yes.
Now, you guys onboarded only a couple months ago, so I think a lot of people in the Chainlink community are still a little unsure, like, what is JOJO Exchange? Can you tell us a little bit about that?
Yeah. So JOJO is a decentralized perpetual contract trading platform built on Base. So we now have the leading trading volume on Base. We provide 1,000 times the leverage, multi-assets, collateral, and advanced trading bot. We are building on Base to perform the best trading experience with a secure on-chain settlement.
Got it. And you guys integrated Chainlink data streams only a short while ago. Can you tell me a little bit about what that's done for your exchange?
Yeah, so that really helps us a lot. So after integrating with Chainlink's data stream, we can provide higher maximum leverage for our users, and they are really happy about that. After integrate with Chainlink's data stream, we can perform the Oracle price updates much faster than before.
Got it. And up here on the podium, we see basically a little diagram of what you guys are building with the AI silicon-based exchange.
Yeah.
Can you go into a little depth there?
Yeah, so that's our next step. We are trying to build an AI-based exchange that transforms the control from human team to a complex AI agent system. And it's very crucial to have a high-quality data to feed and train the AI system. So we chose Chainlink because Chainlink's data stream provides the most real-time price with low latency and high quality and high reliability. And to achieve this, we need the support from Chainlink, and we really feel good about it. Our AI agent system will collect all the market data from Chainlink's network, and it generates some of the whys for our traders, like whether you should long or short Bitcoin. And then after one click, the agents will help the user settle all the trades on chain.
Awesome.
Yeah.
And people can sign up on the whitelist there. There's a QR code on the page.
Yeah.
And they can reach out to you.
Cool. Join our whitelist. We will release it just in 1 or 2 months.
Awesome. Thanks a lot. If you want to learn a little bit more about what we're doing with Chainlink data streams, tomorrow there will be a panel with Lei and a number of other of the leading voices in this space. And there will also be a data streams deep dive tomorrow on the spotlight stage. Now, I think Lei is one of the most creative developers in this space, but we have thousands and thousands and thousands of them, so we need a lot of tools for this. So I'd very much like to ask Ghando back on stage to go into the developer ecosystem.
Thanks, Raoul. That's right. Thousands and thousands of developers. We're really counting on the developer community to build this industry. So let's talk about our developer ecosystem. First, our build and scale programs. With hundreds of projects involved in the build program, we're supporting the most innovative and exciting projects out there. We provide marketing support, technical advice, and also early access to some of our products. And our scale program, with over a dozen projects, blockchains, and L2 networks, taking benefits from enhanced access to our services. Over the past 5 years, the Chainlink developer community has grown to become the biggest and some of the most active in the entire industry. This year alone, we've had over 2,000 developers join our online boot camps for CCIP and RWAs. And hundreds of developers attend our hackathons, including the one we did at ETH Global and Hacker House that we just had over the last couple of days here. This excitement from developers is really the motivation for us to keep building new tools, new initiatives, new quality of life upgrades to make your life better and better when you're developing on the Chainlink platform. That's what really motivates us to keep going. We have updates for you on the Developer Hub. We're bringing you a more unified experience, everything that you need in one place, no more jumping around, all of the resources, developer utilities and tools to help you along the way, no matter where in your journey you are, change logs to stay up to date with all of the Chainlink features that are coming online, demos to give you ideas, code repos to help you kick off your project, and we're even featuring some community-built projects for you to observe and get ideas from. We're providing also architectural diagrams if you want to dive into the technical details. and Chainlink Local, which is an installable package that gives you all of the Chainlink services running on your local machine, so you can experiment and boost your efficiency as you develop. You can do that for CCIP, for data feeds, VRF, functions, automation. This is a huge boost for efficiency. And some of our community developers are already using this tool, as well as some developers even in the capital markets. We're also delighted to announce home.chain.link, the Chainlink Home. This is based on feedback that we've heard from our community, and we're delivering for you. This is a one place to manage all your VRF functions and automation deployments across all of the chains that you have them deployed, all at your fingertips in one spot. And we're excited to launch the Chainlink certification program, which just launched at this Hacker House and had over 130 developers participate. You know, this industry is going to really change the world, and it's going to happen fast. And that means that the people that are building it have to get it right. So this is about knowledge transfer and really upskilling the developers, because we're counting on them to build this industry. This certification is developed by top industry experts. It's got hands-on workshops, interactive sessions. Of course, this comes with a grade, an industry-grade credential that you can show off, and it's completely free, just for you. We've also launched a 17-hour blockchain development course in Mandarin. This has gained over 30,000 views already in the last few weeks, and it's on track to be one of the most popular educational videos we've put out there. No other Mandarin-speaking web development, Web3 development education exists at this level of depth. Try it out. We really think you're going to love it. The educational offerings we have, I really love, and they're great. But I know that some people out there are really already experts in this space. So this next section is especially for you. Please join me in welcoming Uri Sarid, our chief architect, on stage to share with you what he's been cooking up behind the scenes.
Thanks, Ghando. Hi, everyone. So you've seen this slide before, right? It's architecture, but it does tell a story of what can be achieved, what has been achieved across a very broad set of DeFi protocols and TradFi use cases and institutions that are all powered by a combination of Chainlink oracles and blockchains and their smart contracts. And it works because it's highly reliable. Our public oracle network is decentralized, and the oracles get together and coordinate via a Byzantine fault-tolerant protocol called OCR. Plus, we've built up very solid experience on how to release reliably and how to enable our NOPs to operate reliably. It works because it's secure. As you saw from Ghando earlier today, Chainlink oracles have published over 15 billion messages to public blockchains and have enabled over $16 trillion of value on public permissionless blockchains. That's amazing. And it works because it's verifiable. So much of our configuration is open on public blockchains, and the source code is available for public inspection. But so far, we've had one big limitation. These use cases have been focused around things that we saw at Chainlink are really important. We've not made it easy to put all this power in your hands, and that's now going to change. So I wanted to share what we've been cooking up so that all of that power can be applied to your use case, however you want it. But let's take a step back to figure out how to do this. So as you know, blockchains use cryptography to create an immutable, write-only ledger, and then numerous nodes that synchronize in a decentralized manner in order to produce consensus. And that consensus across decentralized operators is what then gives blockchains their amazing properties, like an immutable, known good history. The smart contracts then give you a programming model on top of that distributed ledger. right? Built on a well-defined state machine and predictable execution, which is again founded on consensus. And then you can take that consensus for granted when you're writing the smart contract code, right? You don't think about all of the nodes that are running independently because you're writing against the virtual machine. And in that virtual machine, you know that whatever you write will be executed reliably, securely, and verifiably. But all this state and all these interactions are internal to that chain by design, right? By design, they're living in their own world. And we know that while it works great inside of that one world, there are other worlds out there. And each one has its own contracts, and each one has its own ecosystem. And the consensus models vary a little bit across some of them. And the assets and the contracts on those chains vary. And in fact, there's a very important ecosystem, as we know, outside of any blockchain, right? There's a lot of data out there that's really, really important. We've been serving that data for years. And it's often available behind Web 2 APIs. And some of that data, some of that information is available only behind messages, such as the Swift messages that coordinate a lot of the traditional finance systems and banks and institutions. And of course, there's a huge array of Web 2 systems that are providing not just data, but also interactions that power the traditional financial world. And so, if we want to pull all of that together, we need to involve oracles, if we want to do it in a reliable, verifiable manner. We need, in fact, decentralized oracle networks, as we know. And these oracles will need to connect with these various APIs and the messaging systems and the Web 2 systems. And sometimes they need to call them multiple times and aggregate the data in some way. And sometimes they need to call them only once, because it might be expensive to call or because they might have side effects like creating a resource. And sometimes you need to listen for calls or events that happen and react once you know that all those things happen. And consensus has to be thought of a little bit differently in each one of these interactions, right? So after they connect, you also need to perform often some custom logic and use consensus to make sure that that logic has worked reliably and securely. And the oracles will need to read and write to the various chains, each with their own consensus model. So we see there's a lot of variation in how you need to actually deploy consensus or work with consensus in order to get the properties that you expect. And again, what are those properties? First, reliability, that what we say will happen will indeed happen. Second, security, that nobody can get in the way of that. And third, verifiability, knowing with certainty that what should have happened did indeed happen. So that's, of course, what the oracles, working with the various blockchains and their smart contracts, are going to need to achieve by the various forms of the consensus. And they'll need to work together in this careful choreography to get just the right connections, just the right compute, just the right blockchain interactions with the appropriate consensus mechanisms in each one of these things in order to get you reliable, secure, and verifiable execution. Okay. What do we call this? Consensus computing. This is an age of consensus computing, right? There's consensus of various types all across these things. And we ask, how do you program oracle networks and smart contracts to achieve all of that consensus and get you those properties that we just talked about? And that's the key to being efficient and effective in this world. Now, we've worked hard for years to figure that out, to understand how to achieve it and adding more and more use cases. And today, I'm going to talk to you more about making it programmable, to make it really easy to achieve any use case, your use case, very, very quickly. So, as you know, as you heard from Sergey, we've been building the Chainlink Runtime Environment, the CRE. It's a runtime for DONs, a runtime for decentralized oracle networks. And it automatically gives you just the right consensus model for your particular use case. Now, just like any good runtime, it completely abstracts away all the hard bits. You don't have to think about them at all. In other words, it gives you a simple programming model for DONs. Let's visualize how it works. So let's say you have a particular use case. You have some data that sits behind some APIs. You need to pull that data, do some compute, write it on blockchain C. So what do you need to do in order to make that happen with those properties? You create a workflow, which simply says, get some data, do some compute, write it to chain. That's all you need to do. Just tell us what it is that you want these oracles to do. And the workflow DON will load your workflow and start to execute it. It first communicates with a connect DON to call the API using the calling pattern that you requested. And then it communicates with a compute DON in order to do the custom code that you asked to do, say transforming the data or extracting the data. Now, these DONs could be a logical overlay over exactly the same nodes, or they can be completely separate DONs that communicate with each other. And you don't need to worry about any of that. And finally, you get a chain writer DON that has just the right RPC and the logic to write to chain C. And that's a lot of orchestration, a lot of cryptography, a lot of synchronization to achieve the consensus properties appropriate for each one of these steps in your workflow. But your workflow can be super simple. Now, we call each one of these building blocks a capability. So what you're doing is orchestrating these capabilities. And that capability, each capability, is executed on a DON that has exactly the right properties in order to achieve that particular capability. So as you see, what we've done is we've broken it up into units called capabilities, building blocks, that you can then assemble through simple code. Now, your workflow is written in code. It can be Go, it can be TypeScript. We compile it down to WASM, and that WASM is then what's actually executed on the appropriate nodes. So in your code, you simply invoke the capabilities. We'll see an example of that in just a second. And the execution, the coordination of the DONs for each one of the capabilities that you called, and then combining them with a consensus overlay, that's what the Chainlink Runtime Environment provides you, the CRE. Now, to accomplish this, we did need to re-architect in a significant way the Chainlink platform. And we needed to break it down into these capabilities. And those capabilities are those building blocks. Let's walk through them. So the foundation is a unified interface for interacting with blockchains, where the specifics of each chain are indeed taken into account, the consensus model, the RPCs, and so on. But in the end, they're surfaced as common interfaces for all the rest of the platform, a chain reader and a chain writer. Now, you can have a DON in the end for Solana, you can have a DON for Ethereum, and so on, and these DONs will communicate and will be very, very simple for you to interact with any chain that way. So the programming for any such DON is exactly the same. Now, reading and writing to these chains is just some of the capabilities. We also have, of course, compute to actually run your code. We have an outbound API where you can call any API out there. There's a key value store to provide you permanent persistence as much as you need in the middle of your flow. There will be an event store to have an immutable write-only history of just the information that you want to write. And very importantly, a policy engine that allows you to define policies that can be instantiated and can be checked against without having to write the same custom code over and over again. So these are configurable policies. And again, remember, every one of these capabilities is mapped to a DON that has the functionality to provide that particular capability. Now, there's two kinds of capabilities. There's capabilities that you execute inside of your workflow, and there's capabilities that trigger your workflow. So for example, inbound API calls can trigger a workflow, or receiving a message or an event can trigger a workflow, or you can run these workflows on schedule. So these are all the capabilities, and there will be more over time, and eventually you'll be able to write capabilities yourself. Okay. Now, the CRE is what pulls all of this stuff together. It executes the workflows whenever the triggers fire, and then it uses dawn-to-dawn communications so that these dawns can, in fact, be coordinated across each other. Let's look at an example of exactly this kind of flow, this time in TypeScript. It's just a lot easier to read. And in this case, this example will provide net asset value, or NAV, to a tokenized asset on a chain. So let's actually walk through this. At the beginning, you can read in your config, right? This seems trivial, but it's really important because it means you can reuse your workflow over and over again simply by changing the config. And you have easy access to it right inside of your code. Now, the first step when this is triggered is to get the nav from the API. You see that inside of the connect dawn, we include a little bit of custom code to extract the API from the response of that API call. And we're reaching consensus on the median in this case. All of this is changeable through your code. Now, just like any code, you can easily log anything that you want, and you don't have to think about the fact that it's running on numerous nodes across various dawns. You just log it, and it'll be produced on the observability stack on the other side. And finally, you can see how easy it is to write the chain. Which chain? Whichever chain was inside of your config. So again, you can just reuse these flows across lots of chains. And finally, we register this particular workflow to run on a regular schedule, which you can configure through your configuration. Now, that's all it takes for the CRE to coordinate swarms of Chainlink nodes and blockchain nodes to reach consensus and execute things reliably, securely, and verifiably, as you've come to expect from Chainlink, except now it's your use case. Now let's look at another example. We saw this earlier. Sergey explained the context of this DVP interaction across lots of institutions and Swift messages and so on. DVP, as you know, is a common process inside of traditional finance. You can have the payment, the P part of the DVP, for example, happen off-chain while the delivery is happening on-chain and so on. And you end up orchestrating a lot of things and a lot of messages. But with the CRE, it's just more of the same steps that you saw. In this particular case, this is a TypeScript version of the Golang we're actually using. And I'm not going to walk you through all of this. It's just lots and lots of steps like this. And in fact, there's lots of workflows that institute this. But let's look at a couple of pieces of this thing. One is we're using a key value store in order to map accounts from their off-chain Swift message equivalents to their on-chain identities. And we're using the policy engine explicitly to check whether these particular things are compliant, for example, against some attestations. So that's what it looks like. It's very, very simple in the end, and a lot of stuff that happens underneath that. How do you see what that stuff is? Well, in fact, here is a UI of an application that we built recently, and we demoed at Sibos last week. What you're seeing inside here is the individual events that are happening in various places, off-chain, on-chain, all brought to you through this interactive UI that makes it really, really simple to figure out what in fact is going on. You don't see lots of nodes, you just actually see the functional events that are happening, and of course you can add your own events to this thing. So the platform is real. It's being developed as we speak, and we're excited to take it to production in order to be applied to use cases like the Swift DVP one. And here's a preview of a web console that you'll have that allows you to, I remember that was a workflow manager in that architecture diagram. This allows you to actually launch workflows, see which ones are working, understand their status, and also get notified of any problems that have happened so you can get in there and debug them. So what's the status of all of this good stuff? Well, first, we're really dogfooding it ourselves. We're making sure that it'll be ready and easy to use by first starting ourselves. And we're doing that by putting this in the hands of our engineers that are customer-facing, not our product engineers. The product engineers are building the developer experience, and they're building extra capabilities. But it's the customer-facing engineers that are sort of our first line of give it to someone else and see whether this thing is actually working for them. Can they be successful? So we're dogfooding it first. Now, the architecture is already starting to accelerate us. So for example, having one place of integration, chain reader and chain writer, allows all of our functionality to immediately be available on those chains. And in fact, the configuration is much easier because the DONs are relatively static and you only compose across them. Now, we're using it ourselves, as I mentioned, with other institutions just like Swift in order to enable real-world use cases. And it's a really good place for TradFi and DeFi to come together. It's the same platform, and each side will add in their use cases and will stretch what the platform can do, and the other side will be able to benefit from that. So I'm really excited that this is literally a place where they come together. The final question you might ask is, when can you get your hands on this stuff? It's November 2024, so I'm happy to say that all of this will be in your hands next year. And if you want to sign up for early access, you saw this QR code before, so let us know what your use case might be, and we'll get you some early access to this. Thank you very much. Let's bring Sergey back up.
Yeah, so when Uri showed me what he was developing with our team and the fact that he has working code that can execute that level of complexity across Oracle networks, multiple blockchains, whether that's for data or whether that's for coordinating a payment system like Swift, the type of stuff that you just saw happen in a few lines of code would have taken weeks or days in the past. And it's something that a single developer can now build with a single language that they already know over the course of a few lines of code. So we're really going towards a world where all the learning, all the capabilities, all of the services, and all of the interactions we've had with both the DeFi community and the capital markets community are resulting in a product that can let people build advanced applications across chains that are deeply integrated with their existing data systems, payment systems, and assumptions through the type of code you just saw. Whether that's Go code or TypeScript, two very popular languages, are executing really complicated, really critical steps, coordinating critical systems in a secure, reliable way. Basically, when I saw this, it was very clear to me that this is the future of how these applications are going to be built, because it's the right way to use Oracle networks, for one, which is where all the services are. But the other way is that it is the simple, direct way to actually build the application, and it is exactly what developers are used to doing. So really, when I first saw this, it kind of just blew my mind. The other thing that I'm really taking away from all this, what I've seen on the stage today and at the conference in general, is that we've had Anurag on stage, who works at a trillion asset under management institution, one of the largest institutions in Australia. And we had Jakov on stage from Lido, one of the most successful Web3 DeFi projects. And both of them, in their separate use cases, are talking about using the Chainlink standard for one set of problems and another set of problems. But the really important thing for me is that they're both talking about using the Chainlink standard. So they're both getting on the Chainlink standard. Initially for one use case and another use case, but then once they're on the Chainlink standard for that piece of data or that cross-chain flow, it's very natural for them to adopt the other parts of the Chainlink standard. And then once they get the CRE in their hands, their ability to use the Chainlink standard and its services will become 10 to 100 times simpler. And they'll, I think, realize that building their application through the CRE in a way that it interacts with all the Oracle networks, all the chains, all the data, all the payments, is really the simple way for them to use their limited resources to build a reliable application. So this is really the world that I think we're going towards, that I'm very excited by. And I think I'm really starting to see it form in the early stages here on stage with us. I think the next stages are Anurag, Jakov, other people like them, get more and more on the standard, and start interacting with each other using that standard. That's the next stage of what I hope to see on stage here sometime soon. So it's been a great first day, a lot of great collaboration, a lot of great innovation in Web3, DeFi, and TradFi, a lot of great steps towards bringing those communities together in a productive, useful way. Really thrilled to see many of you. It's been a great first day. There's a lot of great updates and things going on tomorrow. I'll be here moderating some panels. There will be those presentations I mentioned in my presentation. And excited to see all of you here back tomorrow. Even more exciting stuff coming up then. Thank you very much.